In this orthokeratology case, the patient's got a fair amount of against the rule astigmatism that we're trying to get rid of, and we've made some progress, but kind of got stuck with about a diopter and a half remaining in the post-wear refractions. So looking at this case, one thing that I see that might be a concern is the patient only has about a diopter and a quarter of corneal astigmatism. And so even if we were to mold out 100% of the cylinder that's on the cornea, the patient would still be left with about a diopter and a half or so of astigmatism in the refraction. So in order to be really successful with this case, not only do we need to mold out what's on the cornea, we actually need to mold in some with the rule astigmatism. And so not a very easy thing to do, but the patient sounds motivated, so we made some progress. So this is kind of how I kind of continue with this case. One thing we can do is increase the disparity between the meridians. So right now we're at 2.25 in the horizontal and a little bit less than 1 in the vertical. So we've only got about maybe a diopter and a quarter or so of disparity between the two meridians. And if we're trying to really mold cylinder out, we probably want to increase that a little bit. So what I would do is, so about 1 there, I'd aim for a differential of about 2 diopters, so 293 in the horizontal. This will be in 50% mode. Pretty close. So we can do the same thing on the other side since this is a freeform lens. Okay, so now we have a little bit more of a gradient between the vertical and horizontal meridians. Another thing we can do is, in trying to mold in some with the rule astigmatism, is to decrease the sagittal depth of the lens in the vertical meridian. That should cause the lens to rock a little bit across a horizontal fulcrum, if you will, and that may induce some corneal toricity. And again, if we look at the numbers, we actually don't want a spherical cornea. We want a toric cornea that's got some with the rule astigmatism to cancel out the internal cylinder that the patient has. So in a case like this, I'd probably aim for about a 10 micron lift in the sagittal depth of the vertical meridian. Again, we'll be in 50%. And if we're starting at 1991, our new target will be about 1981. So we'll just lift the periphery here. And again, because we're in freeform, we'll do the same thing down here. 2055 will become a 2045. So all these adjustments are based on the assumption that the current lens is centering quite well on the patient. If the current lens is already decentering, then we want to make some other changes to address that. So this is working on the assumption that the current lenses are quite well centered after wearing it at nighttime. So now we have a lens where we've got a little bit more power discrepancy between two meridians. Also a lens that's going to land in the periphery much earlier in the horizontal meridian. There's going to be more clearance superiorly and inferiorly, and that should, or that could, hopefully mold some toricity into the cornea to get this patient closer to plano. So this would probably be what I would try next for the patient, and hopefully get some success and get the patient seeing a little bit better. So thanks for watching. Best of luck.